Good evening all of you in this session on tutorial series of MATLAB. This is the third series on the MATLAB. Today this series is completely based on basic operations on matrices and arrays. Matrices and arrays play a very important role in many ways: machine learning, deep learning, data science, data analytic, image processing, and many more. So the fundamentals which will be discussed today in this series are very important, and the foundation for all these applications in various ways. There are similarity between operations of arrays and matrices, and all these fundamentals must be very clear. Sometimes when we have data in the form of Excel format, and when we import this Excel file in MATLAB for statistical analysis, for prediction, for any type of analysis, then the operations which we employ in matrices also applicable on that particular data which is in the form of Excel. Because all the informations which we store in MATLAB is always in the form of matrices, and whenever we import the Excel data in MATLAB or any kind of data in MATLAB, that will always be in the form of matrices. So the operations which will be discussed today are very, very important and very useful. So first I need to share my screen with you. This is my MATLAB. Along with this is the presentation. Okay. If you have any question related to the ongoing session, you can put your questions in the chat box. I can see all your questions if you will put there, and I will try to justify you all the questions which you will submit in the chat box. Many participants has been joined, and I am waiting some more participants will be soon with us. So the topic which we cover for the matrices and its applications we will cover here: vector product and transpose, creating matrices, adding and subtraction matrices, how we can multiply the identity matrix. Then we have inverse and determinant of matrices, matrix power and exponential, the canonical tensor product, eigenvalues and eigenvectors. So these are the topics which we will cover during this lecture. I am pleased to be in the class today. Greeting, Professor. Thank you, Abud Enozi and Osmane Fombe. Good evening. Good evening, all of you. So these are the content which we are going to cover, and as soon as we will go ahead, we will mention all these topic. Yes, many times the participant asking about the recordings. I let you know that the recording of all the sessions will be available here. Okay. Don't worry about the recordings. I will not remove these live lectures. You just need to visit on the MathTech Thinking Foundation YouTube channel. You can easily access. When you will go to the YouTube channel, there is you need to search MathTech Thinking Foundation, and you will get the YouTube channel. And then after, you can easily access the list of the lectures on MATLAB tutorial series. Okay, so all the lectures are available in MATLAB tutorial series 2023 playlist. Okay, so don't worry about that. All the lectures will be there, and you also in the coming lectures I will explain you about our app is also at the final stage, and very soon we will provide you the mobile app also, so that you can easily access all the things, all type of activities which we are going to organize, and the lectures of this series as well also will be available there. Okay, in the same sequence. And in the coming days we are avoiding the WhatsApp group also. Whenever we have the final mobile app, then all the communication will be best through mobile app. So by this way, this will be very less disturbance for you also. So I was talking about this topic, vectors. There are several types of the vectors, and we will cover under this row vector, column vector, length of the vector, how we can accessing the element of the vector, manipulating element of vectors. Then we have transpose of a vector, scalar multiplication, vector addition, and so on. Jitendra Kumar, Surbhi Parekh, plus AC, good evening all of you. So first we are dealing with the row vector. We have very simple, v is equal to v1, v2, and so on, vn. These if we have a vector, row vector can be expressed in this form, and v1, v2, v3 are usually scalars. Either these are real or complex. And also along with the I let you that the commands which are available in the boxes. Okay, these commands are usually used in MATLAB. So when you will enter in the prompt this one, v is equal to 1, 2, 3, 4, 5, and when you will enter, then we have the vector v. This is the output and this is the input in the MATLAB command window. So this will appear like in this way. Either you can use comma at its place, okay, if you are not using space. Either you can use also space in the place of comma, and you can see that both have same meaning. There is no difference. Okay, you can see in the MATLAB also. Just see here. This is a command MATLAB window, and I have v is equal to if I am entering like in this way, 2, 3, 4, 5, and when you will enter, I have this vector. The another way to representing the vector, suppose v1 is equal to, I can use also the space, 2 space 3 space 4 space 5. Okay, and when I will enter, both v and v1 both are same. So either you can use comma or you can use space. Okay, both the ways are same. Now we have a column vector. V is equal to, you can see here the example of the column vector, and v1, v2, v3 and up to vn are the scalars. Either these are the real or complex. Okay, so when you are going to enter a vector in MATLAB, then this will be used in this way. Note this point very carefully. W is equal to 1 semicolon. Here we have to use semicolon in the place of comma. Then 2 semicolon 3. So when you will enter, we have the corresponding vector. W is equal to, we have the element 1, 2 and 3. If you want to find out the length of the vector, this is very quite simple to use here. The command is length v. This is the function, and this function is inbuilt in the MATLAB. The same function will be used for either it is row or column. We use only the length command, and you see that if we have v is equal to 1, 2, 3, 4 and 5. 5 elements are there, and when you will use this statement and when you will enter, this is the answer. This is the answer because there are 5 elements. The length of the vector is 5. Okay, in this way we can use. And if we want to extract the element corresponding to the position, if we want to find out the element or want to access the element corresponding to the position, we can do. We can access the element vector v at the position k, and with the MATLAB indexing vk. Or if we want to extract the multiple positions, then we have to use in this way v, k1, k2, k3 and up to kn. See here v3 is equal to, if we want to access the third element of the element at the third position, okay, we have to insert the statement in this way. If we have v is equal to 1, 2, 3, 4 and 5, this is the vector, and we want to extract this element, and this element is at the third position. Okay, so when we will insert this statement, this will be equal to 3. I have to change this vector. See one more example. v1 is equal to, if we have 2, 5, 7, 9 and 10. Okay, and if I want to extract the third element, and third element is 7, so this element will return at this place. See in the MATLAB also. Yes, here is in vector v we have 2, 3, 4 and 5. Okay, so when I will extract the third element, there are only 4 elements here, and fourth element is we have equal to 5. So if I will extract the fifth element or the element at the fifth position, see what happened. There is no element. Okay, because the length of the vector is 4. So fifth element does not exist. So what I have to do? I have to extract the fourth element. Okay, and the fourth element you can see is 5, and here is also 5. Okay, and the first element in the vector is 2. First element, if you will extract, this is equal to 2. Okay, so in this way we can easily access the element from the vector. Okay, one row vector, one column vector are equivalent to arrays also. Note this point very carefully. In the MATLAB, array and one row or one column vector are equivalent to arrays. So now, this is also very important. Sometimes if we want to change the values of the vector or the some element we want to replace, then we can do. Here we want to manipulate or assign the values first, third and fifth element of the vector. Note that vector on the right must have the same length as the area to which it is assigned. Yes, this is very important. Suppose that we have v is equal to 2, 3, 4, 5, 6, 9, 10. Okay, we have this vector, and this is the first element, second element, third element, fourth element, fifth element, 6 and 7. So what we are doing here, we want to replace the first element at the first position, element at the third position, element at the fifth position. Then this is the statement on the left hand side, and now we want to assign new values. For the first position we have -10, for the third position we have -20, and for the fifth position we have -30. So what happened when we will and is equal to this one? This is the left hand side, and the positions of the elements which we want to replace is 1, 3, 5. 3 elements we want to replace with the new values which are -10, -20, -30. So this statement will replace the corresponding element, and we have new vector, and new vector will be this one. So all these values, this value will be replaced by -10, this also will be replaced by -20, and this element will be replaced by -30. Okay, see in the MATLAB. I gave you here one more example. V is equal to, we are choosing very interesting example here. I have 2, 4, 5, 7, 8, 9 and 10. Okay, I have this vector. So now I want to replace the element which is at the first position, the element which is at the third position, the element at the fifth position. Okay, so this will be equal to I wanted to assign these values, first by -10 and second by -20, then we have 30. Okay, whatever you need, you can change anyone, but I am choosing here -10, -20, -10, or if you want to change, then you can do also. Okay, so when I will enter, I have new vector. You can see this is the vector V, and now we have new vector, and first element is -10, second is 4 is at its place, and when you will check, 2 is replaced by -20. Okay, and here is 4, here is also 4, here is 5, -20, here is 7, here is also 7, and so on. So these elements has been replaced according to their positions, and positions are 1, 3 and 5, and these are the new values which we want to put at these positions. Okay, so the thing is which you must be note here, the number of the positions and the new values, number of the new values must be equal. If these are not equal, then this will return no value and there will be an error. See, once again, if we have in this way, if the statement is in this way, On the left hand side we have 3 assignments, 3 positions, but we are going to assign 2 values only. So when I will enter, there is an error, unable to perform assignment, because the left and right sides have different number of elements. So the number of elements which we are assigning must be equal, only then we can this type of operation will perform. Surinder Kumar Agarwal ji and Mr. India, Tata greeting. Jyotsna, good evening all of you. Today you got late to join this meeting. Also, if you have any question, you can put in the chat box. I will get it and I will try to justify you. Okay. I think you got it. Now, here is the transpose of a row vector is a column vector, and transpose of column vector is a row vector. And we can do by using here is the definition. You can see this is the definition for the transpose. We have a vector, a column vector, and transpose of it will be row vector. Okay, and this sign will be used in the MATLAB. Okay, you can see here is the very simple example. U is equal to, we have, this is the column vector, and when you will use U dash, so this will be equal to column row vector. Okay, column reduced into row. We come back at MATLAB. We have V is equal to this one. V is row vector here, and if we do here this sign is used for transpose. So now the row vector becomes column. You can see again you can use in this way. V is equal to V1 is equal to V dash. Okay, and if you will write again, you will take the transpose of V1. Suppose it is V2 and V1 transpose. Okay, so this will be again row vector. So you can see V2 and V1, V2 and V1 and V both are same. So here is V2 and this is V. Value of V2, check again. Yes. So value of V and V2 both are same. So when you will take a transpose of transpose, then it will return the original vector. CLC is the command to clear the command window, as you know, and whose will return all the variables which are available in the workspace. You can see on the workspace, and in the first column we have all the variables. In the second column you can see the size of there, and then we have bytes, class, attributes. You can see all this. CLC. Now again come to the presentation. Here is a scalar multiplication with vector. A scalar is a number usually selected from the real or complex number to multiply a scalar times a vector and simply multiply each entry of the vector by the scalars. You can see if we have a vector and we want to multiply with the scalar alpha, so this is the vector V, and all the elements of the vector will be multiplied with alpha. So all the component of vector v will be multiplied with this scalar. And here is the example. You can see 2 is a scalar and 1, 2, 3, 4, 5 are the element of the vector v, and when you will multiply with the scalar, all these will be twice. So here are also some examples in the command for the MATLAB. Also you can check here, v is equal to, we have a vector from 1 to 5, and there are 5 elements only. W is equal to, we have 2 product v. So vector v is multiplied with this scalar, and we get these values, which is the same example as you can see at its place. And similarly, if you have the column vector, you can do v is equal to, we have this one is the column vector, and the elements are 1, 2, 3, and w is equal to, we have 2v. Okay, this sign is the product sign. So when you will execute this statement in the prompt of the MATLAB, you will get these values. Okay, so I am presenting here only one example. You can check it. Sorry, v is equal to, we have this element 1, 2, 3, 4, 5, and if I multiply to vector v with 3, okay, this is the vector, and when I will enter, so all the elements of v are 3 times at its place, because we multiplied this vector with 3. And if we have v1 is equal to ans, okay, so v1 have this element, and if I want to take the transpose, v1 transpose, okay, v2 is equal to, I have v1 transpose. Is there any mistake? Yes, there is mistake. v2 is equal to, we have v1 transpose, and v3 is equal to, we have 4 product v2. Okay, so what happened, you can see all the elements are 4 times here. So in this way you can apply numerous operations according to your requirement, your choice, your interest. You can do many things. I think you got it, and very simple operations. Now, vector additions. Vector addition and array additions both are same. These are also element by element addition, and the length of the both the vector must be equal. Only then we can their addition is possible. So here this is the one vector and this is the another vector, and v and w. So you can see the length of both are same. Here are in the first one we have n element, and in the second we have also the n element, and when we add to these two vectors, or here is we will get the same order of array or vector. So u1 will be add in this one, and u2 in v2, and so on in this way. So first element from the first vector here is, and second element from the first element from first and second vector u1 plus v1, this one, and this u2, and here is v2, u plus v2, un and vn, and here is same. So this type of addition is known as element by element addition, and if there is array multiplication, in that case we have to keep in mind their sign of the multiplication. That is also very important, and I will explain it with the example. So first see here, we have this is the u vector having the 4 element 1 to 4, and v is equal to, we have also 5 to 8 element. These are also 4 element. So the length of this u and v both are equal. Length of these two vectors are equal, and when we will add u plus v, so you can see 1 plus 5 we have 6, addition of these two element we have 8, addition of these two element we have 10, and addition of these two element we have 12. So the same rule is applied in the MATLAB also, and you can see carefully. Similarly, if we have the column vectors, these are two column vector u and v, and addition of these two, 1 plus 3 and 2 plus 4, we have 4 and 8. Okay, so the addition of these two vectors are very quite simple. Okay. If you can apply these operations in your MATLAB, and all these are very quite simple. Now we have matrices in MATLAB. So before starting this one, matrices in MATLAB, I would like to explain about array multiplication, array exponent. These are very important to know, because when we have array, in that case many times we have to face many problems. Come here, CLC. I have x is equal to, we have x is equal to 0, then colon 0.01, and then I have 2 pi, only pi. Okay. If I am choosing here y is equal to sin x, if I have sin x, very simple function, and plot, see here, when I enter this one, then there is no error, no message. So the statements which I entered here are quite simple, and we can plot it. Okay, we can plot it, x comma y. We have this is the result for this one. And also you want to get the x and y, then we have the values, corresponding values of these two also. Okay, x and y both are there. Okay, so but the problem is that if I have a function y1 is equal to sin x and product cos x, and when I will enter, you can see here is error. Now this is the error. Why? The problem at this place is multiplication of two arrays or product of two vectors, and that product must be element by element. And why this problem occur with us? see, here is, this one is, sorry, yes, this sin x and cosine x, these are two functions. So this will generate one array and this is another array. Okay, suppose it is v1 and this is v2. So v1 and v2, then in that case a1, a2, a3, here is b1, b2, b3. Then this multiplication with the a1, b1. If you are going to multiply v1, v2, then a1 with the b1, a2 with b2, and so on. an, bn, and an must be with bn. So this type of product will be element by element. Okay, and how for this one we have to use one more sign. See, if I replace this product sign with the dot, then there is no error. Now it is correct. Now it is correct. So while writing the code, each concept must be very clear when we must use dot sign or where we should not use dot sign. Okay. So only in the case of arrays, multiplication of arrays, we must note this point. Now we can plot these two, plot of x and y1. You can take it. Now there is no error, and this is the graph of this function. Y1 is equal to sin x into cosine x, product of two functions. Okay, so when you have arrays, in that case, note this point, and you have to use in your programs when you write different type of programs and functions, and you need to call them, you need to use them. In that case, whenever this type of problem occur, you must remove this problem first, and then you can execute the program. Also, y1 cap 3. So cap is used for exponent, but here is, this is the array. Okay, in that case you have to use dot product also. Now it is fine, returning the value y exponent 2. Y itself is an array. Y is equal to, we have sin x, and we want to, y square means y multiplied with y. Okay, so this is the array. Y itself is array. We have to use dot at this place. Now it is correct. X is also array. x1 is equal to x product x. Sorry. Sorry. You can see here x1 is equal to x product x, but x is an array. X is vector. See here, these are the values of x. Okay. So the problem with this statement is that x is one vector and we want to multiply x with x. Okay, so we have to use here x dot, and then it is possible. Okay, and if you want to calculate this value x cube, okay, for exponent and for product, we have to use dot. So x cube means x product with x, product with x 3 times. I think you got these values. If you have any doubt, sorry, Salaudin and okay, Surbhi, Lubam. Okay, so now we are covering the topic matrix in MATLAB. This is also very interesting, very useful, very important, and there are so many applications of matrices in machine learning, deep learning, data science, AI, image processing, digital, control theory, okay, statistical analysis, many more. So the first thing is which topic we will cover here. You can see creating matrices, transpose of matrix, then we have concatenation matrices, predefined scalar matrix, addition, multiplication, addition and subtraction, multiplying matrices, identity, inverse and determinants, matrix, power and exponential. These topics we will cover here. So the first thing is how we can create a matrix or column, matrix or of equal length, or okay. Here is a few examples creating matrix in MATLAB. This is very quite simple. Here is a matrix which have the element in the first row 1, 2, 3 and 0. When you want to break the row, then we have to use semicolon. When you will use semicolon, it means new row will start. And for the row element, either you will use space or you can use comma. Okay, so this is the second row, and the second row have also the 4 element. Then we have the semicolon. This will break the row, and this is the new third row. When you will enter, you will get this matrix. Okay, similarly, you can see this was the matrix, and this is the first row, and these are the element. This is the second row, this one. This is the third row and third row. So when you will use this statement size of A, size of A return the order of the matrix. So in this example, you can see there are 3 rows and 4 columns. See, in the MATLAB, I am choosing here A is equal to, I am choosing here my own choice 2, 3, 4, 5. These are 4 element semicolon. I am using for different element of rows comma, and for new row we have to use semicolon 3, 4, 5, 6. These are 4 element, and then again use semicolon. Then we have 4, 5, 6, 7 and semicolon. Then I am 5, 6, 7 and 8. Okay, so when I will enter and A is equal to, I have this matrix. Okay, if I will use the statement size A, so this will return that size of A is 4 by 4. So this is the 4 by 4 order matrix. Okay. Then come here. How we can access the element? Sometimes we need to accessing, suppose it is 2, 3. The meaning of 2, 3 is second row and third column, where the line will intersect. Okay, second row and third column. This is the second row and third column. This element is 2, 3. So when you will execute this statement, this will extract the element and the value of this element is 0, and this will return 0. If you want to access second row in the matrix, then you will use this statement. And note this statement very carefully. A parenthesis 2 comma then colon. Colon means entire element, all the elements. When you will use this colon, colon means all the elements, whatever in the row or the column. So when you will execute this statement, this will return all the elements of the second row. You can see this is the second row. All the elements will be extracted by using this statement. This statement is A, 2, then colon, this one. If you want to extract all the elements from the column, then you can use this statement. This is the second column, and all these elements will be extracted when you will use this statement. So all the rows, here is all the rows, then comma and 2. Okay. This is the first row element, this is the second row element, this is the third row element. So all the rows but second column. This will extract in this way. Also, accessing submatrix. Sometimes if you need to access submatrix, you can do. See this one very carefully. See. Okay. Here is 1, 3 and 2, 4. What is the meaning of 1, 3? The meaning of this one is first row and third row. Okay. And 2, 4. 2, 4 means second row, second column and fourth column. This is the second column and this is the fourth column. Okay. So where these will intersect? See this point very carefully. Then this one. Then this one. Then this one. So these elements are, this one is 2, this one is -2, this one is 0, and this one is also 0. So this is the submatrix of this one. See in the MATLAB. See in the MATLAB. Okay. So here we have a matrix, and in the A matrix I want to extract 3, 4. So this will extract the element from, this is the third row and fourth element. This must be equal to 7. Yes, it is 7. What is inline function? Okay, inline function. Dear Randhir Singh Baghel, this will be discussed in the coming session, but today we are covering matrices and row operations. If we have time, then we will cover in the session. Okay. Otherwise, this was discussed in the previous lecture. In the second, you can go through there, or we will discuss in the coming session. Okay. Don't worry if you miss this part. So now we have a three comma and colon. So this will extract entire third row. Okay, this is the entire third row. You can check. Third row is, this is the third row. Okay, see, this is the A matrix, and third row has been extracted by using this statement. If you want to extract first row, then if you want to extract first row, then you will use this statement. So this is the first row. If you want to extract third column, we want to extract third column, then third column will be extracted by using this statement. These are the elements of the third row. If we want to extract submatrix, then here is second row and fourth row, then comma, third row, here is first row and third row. Okay, so where these lines will intersect, we have this matrix. Okay, so we are using 2 4 1 3. We are using this one. Sorry. We were using 2 4 and 2 4 1 3. So where these will intersect, this element, this element, this element, and this element. Okay, and the statement for this one is, we have A, then 2 3, sorry, this is 2 4, then we have comma, and 1 3. So in that case, we have the answer. The submatrix will be these elements 3 5 and 5 7. This is the answer for this statement. Got it? And you can check here. And another way we can use sometimes like in this way also. I have 1 2 3, 1 2 3. Then we have 2 to 4. 2 to 4. So here, see the difference. First 3 rows, first row, second row, and third row. The meaning of this one is first row, second row, and third row. And meaning of this one is second row, third row, and fourth row. So this will be the matrix of 3 by 3 order. Submatrix of 3 by 3 order. Okay, so these are some few examples of manipulating the same. Okay. So in this way we can easily manipulate. I hope you got it. And if you have any problem, you can submit your question. So here we have discussed modifying values of matrices. If sometimes we want to replace the value, we can do. See carefully. If we want to replace the value 3, 4 from this matrix, in this matrix we have this matrix. Okay. Yes. No. 3, 4. 3, 4 means this element. If you want to replace, you can do by using this statement. 3, 4 is equal to 12. So this value will be replaced by using this statement. Okay. So when you will enter this one, and you can see at its place, this is the new value. Sometimes if you want to modify the entire first row, we can do. But the thing is that how many elements are there in the first row? There are 4 elements. Okay. So A, this is the first row. Then colon is used for all the elements, and these are 20 colon 23. These are 4 elements: 20, 21, 22, 23. Okay, so these elements will be replaced. When you will enter, you can see this is the new matrix, and only except this element, second row and third row will remain same. Only the first elements from the first row will be replaced, and these are the new values: 20, 21, 22, 23. You can see. Okay. And if we do here in the MATLAB, you can check here also. The statement we have to use here is A. Sorry, this is A. Then sorry. One and this one. There are 4 elements in the first row. So we have to assign here 4 elements. I am choosing here 10. Sorry, these are 10. Then I have 20, 30 and 40. Okay, and enter. You can see new values has been assigned in the first row. Similarly, if you want to change the values in the column, you can do. See here, we want to replace the value in the second column, but all the elements are same. You can see A colon 2 is equal to 11, means all the elements will be equal. All the elements will be equal. So if you are giving the different values, then you can do, and you can give the equal values, then you can do in this way. So when you will execute this statement, all the entire values will be same. Check in MATLAB also. We have A and colon, then 3 equal to 50 and enter. So you can see in the third column all the elements are 50, 50, 50. First column, then we have second column, then we have third column, and in the third column all the elements now 50. So in this way you can manipulate the elements, you can assign the new values. Yes, mesh grid also discussed, but don't worry. Good afternoon. Sani Saleh is also there. Surbhi ma'am. Randhir Singh. Randhir. Okay. So here is transpose of a matrix is same as the transpose of a vector, and for example you can see here is a matrix, and when you will take the transpose of this A and you will use this sign only, A transpose. In the place of T you will use this sign, A dash. So this will convert all the rows into columns. You can see this is the MATLAB script, and when you will execute all these and when you will return this statement, this will give this matrix. Okay, this matrix is of 3 by 4 order. This will be 4 by 3 order. Okay, so many operations are here. See in the MATLAB. So A is equal to, we have this matrix. If you will take its transpose, then you will use only this one. So this will convert all the rows in column. You can see. So the first row becomes first column, second row, second column, third row, third column, fourth row, fourth column. Okay, so if you will take again transpose of transpose, okay, so the transpose of A and S means this one. This will be equal to A. This will be equal to A. Yes, you can see. This is equal to A. This one. These values and these values are in the same order. Okay. Each corresponding element are same. Dennis, how are you? Today you got late, and I think after a long time you are being the part of this session. I am happy to see you here, Mr. Dennis. CLC. Now come here. These are very important. Matrix concatenation in MATLAB. We have A is equal to this matrix, and this is the order of this matrix. This is B matrix, and the element of B are, when we execute, we have this new matrix B. If you want to combine these two matrices, you can do. We want to combine these two matrices. The statement here is A is equal to A comma B. When you will use in this way, A is equal to A comma B, then this matrix here is, this is A matrix and this is B matrix, and this is new matrix. Okay, so this element will be appeared at its place. Okay, these elements are appeared at its place, and elements of this matrix are appeared at this place. When you are using this statement, A is equal to A semicolon, as you know, semicolon is used to break the row. Okay, so the B matrix will be below of A matrix. So this A matrix will appear at the top. This is the A matrix, okay, and this is the B matrix. So when you will use this statement, then we have in this way. If you want to use in the MATLAB, we can check it through the MATLAB also. This is the MATLAB window, and the layer CLC, I have A equal to we are using here 1, 2, 3 semicolon, 2, 3, 4 semicolon. Then we have 3, 4, 5. This is A matrix, and B is equal to we have 4, 5, 6, and then we have 4, 5, 6 two times. Okay, no problem. Then we have 6, 7, 8. Okay, we have these two matrices. A equal to, if I am using A is equal to, I am using here A1 is equal to, I am using here A1 is equal to A, B. So when I will enter, so you can see this these elements are from A. So the elements of A matrix are in the first, and the elements of B matrix are at its place. Okay. So, and if you are using A2 is equal to, if you will enter here A semicolon B, then first 3 rows are of A, and next 3 rows are that of B. So in this way you can combine two matrices, but while doing this type of operation, you need to keep in mind their corresponding order. Okay, it is very important while using this type of operations. I think you got all these operations, and quite interesting. I am waiting for some questions from your side. If you can submit your questions in the chat box. Along with if please keep in touch till the end of the session. In the end, I will give you some information. That information is very important for all of you. Okay, please keep in touch till the end of this session. CLC. Now, these are some predefined matrices in the MATLAB. Zeros function will give the matrix where all the elements are 0. Okay, and if you are inserting this statement, then this we will have square matrix. I3 will give us the identity matrix. Once function will give us the matrix having all the elements are equal to 1. Magic 3 is also predefined matrix in the MATLAB and give the values. These values, and there are some properties for the magic. The sum of this row, and this row will be always 15, and sum of these element are also 15, and sum of the diagonal elements will also equal. Okay, so this is the magic in the MATLAB. We can use all these in the MATLAB. See, once this will give us I will give us identity element, okay, and once gives us all the elements will be 1, okay. Zeros of 2, 3. Sorry, this is incorrect statement. Zeros 2, 3. Sometimes we need some particular order. Then you can take like in this way. A is equal to, we have zeros of order 3 by 5. Okay, so this is the A matrix of zero matrix of order 3 by 5. You can do in this way. You can use also for the ones matrix. B is equal to ones and particular order 3 by 5. Okay, and magic 3. Okay, this is the magic 3. Magic 4, magic 4. So you will check the sum of these elements of the rows and elements of the column, elements of diagonal will be equal when you will find the magic matrix. Okay. Sorry, today I feel little bit cough I have. Now again come here. Scalar matrix multiplication would be carried out exactly the same manner as scalar vector multiplication. So there is no big difference here. You can see 3A is equal, this is the A matrix, and each element will be multiplied with 3. You can check. Okay. So the same property will be applied when by doing MATLAB. And how? First you need a matrix. This is the A matrix and 3A, 3 product A. This will return these values in the MATLAB. You can compare all these. For addition, subtraction, the order of both matrix must be equal. So you can see here is A matrix, here is B matrix, and when the order of this matrix is 3 by 3 and this is also 3 by 3. So when you will do A plus B, okay, and the returning value we have is this matrix. And similarly, you can do in the MATLAB A is equal to this matrix, B is equal to this matrix, and when you will apply this A plus B operation, this will return the corresponding new matrix. And for matrix vector multiplication is also alpha 1, alpha 2, alpha n are the scalars, v1, v2, v3 and vn are the vectors, and the construction of this one is called linear combination. Alpha 1 v1 plus alpha 2 v2 and so on, alpha n vn. This is the linear combination, and v1 v2 vn are the vectors, and alpha 1 alpha 2 alpha n are the scalars known as weights of the linear combination. So here you can see this is a very simple example. This is the matrix, and these elements are the vectors. Okay, these are the vectors, and these are the scalars 1, minus 2 and 3. So sorry. So when you will multiply, do this operation, so you can see these are multiplied with 1 here, and these are multiplied with the minus 2, this part, and these are multiplied with the 3, this part, this one, this one, this one, and when we adding these 3, we have this one. So if you want to find out the linear combination, then you will proceed in this way. Okay, and we can easily, this is the A matrix, this is the B matrix. You need to multiply A with B, and you will have this one. So in this way you can easily find out the linear combination of the vectors when you have scalars also. Sorry. Matrix, in the case of matrix multiplication, if we have two matrices, this is the A matrix and this is the B matrix, and for the matrix multiplication we have one condition that must be justified. Columns in number of columns in first matrix and number of rows in the second matrix must be equal. Only then we can multiply first A matrix with B, because it is A matrix and this is B matrix. Okay, so the number of columns in A must be equal to number of columns, number of rows in B. Only then multiplication of A matrix with B will be possible. And how it will be possible in the MATLAB? The algorithm is followed by this one. So this matrix with these two, you can see here, then comma, this matrix with the second column here. Then multiply all these first row, first element, then 2 is second row. Similarly at this place also. Okay, and after simplifying we can get this value. But in the MATLAB we have A is equal to this one, B is equal to this matrix, and this is a simple operation, A product B, and when you will execute this statement we will have this answer. Okay, so in the MATLAB we can see one example. This is a CLC, and A is equal to, we are taking here a very simple example, 2, 3 and 4, 5. Okay, this is A matrix, and B matrix we have 3, 4 and 4 comma 5, sorry 5 comma 6. Okay, we are taking this example. So A product B, A product B. Okay, we have this answer. If we have C is equal to we have 2, 3, 4 colon 4, 5, 6. Okay, if we do A product C, so this product was possible because the A matrix has 2 columns and C has 2 rows. So both are equal, 2 rows. But if you do C product A, this is not possible because the condition is not justified. That's why there is an mistake. And if you do this one, this is also not matching because you can see arrays have incompatible size of this operation. Okay, so this is the main thing. The conditions which we studied in mathematically must be justified at this place. Only then this will give the return the answers. Otherwise there will be errors, as you can see here. So identity matrix, these are very simple operations and you can execute. When we multiplied with the identity matrix with A will be equal to same matrix. I command is used in creating the identity matrix as we studied. If you want to satisfy this one, then you can do I is equal to, we have I matrix, identity matrix has been created at this place, and this is the A matrix corresponding to this one. And when you will execute this statement A product I, and it is returning the same matrix, you can see this is the first row, this is the first row, second row element are 4, 5, 6, third row element are A7, 8, 9. Okay. For the inverse and determinant matrix, this is also very quite interesting part. Determinant of a matrix, we have AD minus CD. Okay, and in the MATLAB we have this function to get determinant. Okay, so determinant of matrix we have is equal to minus 39. And how you can get in the MATLAB? We will use this command, this function. First we need a matrix, then we use the determinant function in the MATLAB in this way, determinant of A, and this will calculate or return the determinant of A, which will be minus 39. We have A is equal to this, the matrix A, and the determinant of A we have minus 2. Okay, and B is equal to, we have this matrix, determinant of B we have is this one, minus 2. So the determinant will return us Abused NOZ. Nice sound. Tata. Sorry, doctor. Tata. Okay. Sunny Slay, get well soon, sir. Okay, no problem. And Abud, who knows the M? Abud, I couldn't understand who knows the. Okay. Surbhi, Pradik, these elements are random. Yes. Okay. I think all of you got all this content which I present till now, and if still you are facing or having any doubt or question, you can put in the chat box. Okay. CLC. Inverse matrix. Yes, here is a very large example. You can see here A is equal to, we have this matrix, and you want to calculate the determinant of A, then you have to insert a matrix in the MATLAB, and then you will use this statement determinant of A, and this will give us the determinant of this above matrix when you will execute the statement. Inverse of the matrix. This is also very simple, and first we must be clear about the singular versus non-singular. If the determinant of a matrix is 0, then we say that the matrix is singular. Okay, and a singular matrix does not have its inverse. We are not able to find out the inverse matrix because inverse matrix and non-singularity, we have the relations. That's why if the matrix is singular, we are not able to find out its inverse matrix. But if the determinant of the matrix is non-zero, then we say that the matrix is non-singular. And if the matrix is non-singular, only then this matrix is invertible. And non-singular matrix has its inverse matrix. Okay, and to find out inverse matrix in the MATLAB, we have this function will be used to find out the inverse matrix of the given. So here is B is equal to, this is the A matrix. First we need to assign the values in the syntax of MATLAB. Then we will use B is equal to this statement inverse of A. This will automatically return the inverse matrix, which will be equal to B. Here is a very simple system of equations, and very useful and helpful. How we can solve the system of equations in the MATLAB. Okay, so here is syntax. I think some will be visible, all of you, and some of them will be less visible. But don't worry, I will explain all these things one by one. If you are attending this lecture through the mobile, then the some syntax will be very small. If you are attending this lecture on your system by using laptop or PC, then these texts are very clear to all of you. If you are attending through the mobile, then don't worry. Suppose we have this system of equations. And in the lower classes, we studied about the system of equations, and there are numerous methods to find out the solution of this type of system of equations. Okay. There are some numerical methods are also there. But here we are dealing with the classical method. So these are three equations, and we can easily convert these equations in the matrix format. So the coefficient of xyz, we have this matrix, and xyz variables, and on the right hand side the values, these are at its place. So this system of equations we can write in this form: ax is equal to b, where a is A matrix, x is, we have x matrix, b equal to, we have b matrix. So after converting these system of equations in the matrix form, then we have x is equal to A inverse b. When we will execute this operation in the MATLAB, this will give us the value of x vector, and x vector contains three values, three variables, x, y, z, and corresponding to this x, y, z, we have the values of x, y, z. Okay, so here is in the at this place you can see. So this code I want to expand through the MATLAB. I have converted already. Yes. You can see first we are initializing the matrix A, then this is the A matrix. Okay, this is the A matrix. Then we initialize the B matrix, and B matrix will be this one. After that, we are using here display statement. The purpose of using the display matrix is only this will print the matrix A, and then we are using here display A. So this element will be printed at this place. Okay, so I will show you here. See here what happened. So if you are using these three, this one, okay. So you can see in the MATLAB, just 1 minute. Just 1 minute. Okay. Yes. So I am using here. Yes. Now it is fine. Display matrix A. So when I will use this statement, matrix A will be displayed here, and this statement is printed here. Matrix A. Matrix A is printed here, and then I am using here display A. So the A matrix which I insert will be printed here. This is the matrix A. Okay. Similarly, I am using here display matrix B. So display means this will be whatever is there at this place. The same statement will print here. Okay. So this statement matrix B will be printed at this place, and then display B matrix. B matrix is printed at this place. Okay. Now after that we need to calculate the determinant of A. We need to find out the value of determinant of A. So first we are using display determinant of A. Then we are using here display determinant of A. When you will use this statement determinant of A, this will calculate the determinant, and then it will display the value also. You can see the determinant of A, and then this will be, this is 15 is calculated by using this statement. Then if the determinant is not equal to 0, the determinant is not equal to 0, then we need to find out the inverse of A. So inverse of A is calculated by using this one, inverse of A, and also we are displaying the same. Okay, and after that what we do, multiplying the inverse of A with vector B. So x is equal to, we will have inverse of A product B. So when you will execute this statement, after that display the value of x. So these are the values of the x. Here you can see step by step, this is the determinant of A, then this is the inverse of A, then we have multiplication of A with B, this one, x is equal to multiplication of A with B, these are 1, 2, minus 2. The value of x is 1. The value of x is 1. That of y is 2. And value of z is minus 2. Okay. So in this way we can easily get the values of x, y, z, and at the end we need to verify. And for the verify, you can see display verifying output values by putting values in the equation, and this is very quite simple. Display A into x. When we do A with x, then these must be equal to B matrix, and you can see the values are minus 2, minus 13, 15. These are the same value as you can see here. These values, matrix B, this one we get. Okay, so this part whole I have explained in the MATLAB code, this complete part. If you need this presentation, I will share with you. Don't worry. I understand the problems which you will face. So I have prepared this skit file. All the codes are very clearly written there, step by step. So this is the A matrix. This is the B matrix. What do you need? You need only 3 statements to find out the solution of the system of equations. If you will take A matrix, then B matrix, and then you need to use only this statement, x is equal to this one. See in the MATLAB. See here. I have A matrix. This is the A matrix. I have B matrix, and x will be equal to inverse of A. Inverse of A product B. This is the answer. Only 3 statements are required. You got it? First you need to insert the matrix A, then create matrix B. Okay, then x is equal to inverse of A into B. This will give us the solution. And if you want to justify A product B, A product X, sorry. This is minus 2, minus 13 and 14, 15. Okay. So the values are also verified. And same you can verify from this place. Yes. Same thing is there. See, these are the verified value. Okay. And these are the values of X, Y, Z. Okay. Thank you all. Thank you. So I hope you got all this calculation part, and thank you very much, Jyoti, Jyotsna, Jacob, all the participants who are attending this session live. Okay. Now you can see here matrix power. If we have matrix, then how we can use a raised to power p. P is any positive integer and A is any square matrix. Okay. How we can use? So you can see this cape sign is used for the exponent in the MATLAB. A is equal to, we have this matrix, and first you will assign the matrix in MATLAB, and when you will enter, this is the output. If you want to find out the A cube, then the meaning of this one is A into A into A 3 times. So we are using here A cap. A cap will return us this new matrix. Similarly, if we have A is equal to this matrix, and when we have A raised to power 0, A raised to power 0, we will have identity matrix. Any square matrix with the power 0 will always be an identity matrix. Okay, we can check it in the MATLAB. CLC, we have this A matrix. Okay, we have A matrix, and if we need A cube, so this is the A cube matrix. Okay, and if we need A raised to power 0, this is identity matrix. If you want to pass this value through the sign function, sin A, okay, so A is a matrix, so sin A will give us the matrix sign values. If you want to pass log A may be some error. Yes, you can get this is the log A values. Any function can have this argument. Okay, don't worry, you can check it. Also, exp, exponential function of A, you can pass these values. We have these values in the form of matrix. Yes, we have sometimes if we have E is equal to exponential 1 and E raised to power A, we have these values. Second way is to inbuilt exam function. Okay. If we have E, value of E is nothing. A is equal to, we have exp. A is not inbuilt function in the MATLAB. So E1 is equal to, exponential 1 is equal to, we have A. Okay, which is 2.7183. And if we have e raised to power a, then we have these values corresponding to the same. Or the another way, we have ex pm. We can do in this way also, sorry. Okay, now it's fine. We can use in this way, ex pm a. This is also the function, and we can use for exponential directly. This part is also discussed. Then we have to calculate row power, element of the power. We can do square root also we can find out, nth root also we can find out, nth root. Okay. So for the square root we are using this statement. For cube we are using this statement. For nth root of matrix we are using this one. So 3 means third root, cube root of. Okay. SQRT is the square root of a. And nth root, okay. Nth root of a will give us this solution. Nth root is inbuilt function, square root is also inbuilt function. Okay, all these are inbuilt functions and we can use them directly. There is no problem. Kronecker product. Kronecker tensor product is also very useful sometimes if it is required. Sometimes the product is an operation on the two matrices arbitrary size resulting a block matrix. It is the generalization of the outer product which is denoted by the same symbol from vector to the matrices and gives the matrix of the tensor product with respect to a standard choice of basis. The Kronecker product is to be distinguished from the usual matrix, which is an entirely different operation. The Kronecker delta product is also sometimes called matrix direct product. And in MATLAB it is defined as Kronecker, this is the function which will be used, Kronecker xy returns the Kronecker tensor product of x and y. The result is a large array formed by taking all possible product. Note this statement very carefully. All possible product between the elements of x and those of y. If x is m by n order and y is p by q order, then Kronecker delta of xy will be mp by nq order. Note this statement very carefully. This rule is followed to find out Kronecker tensor product. See here, we have very simple example. This is A matrix, this is X matrix, this is Y matrix. So, what is all possible product? One is multiplied with all this element, see, 1 into this matrix, then 2 into again the same matrix, 3 is multiplied with this matrix B, and 4 is also multiplied with all these elements. Then we expand 1 is multiplied with all these elements. 1 into 0, 1 into 5, then 1 into 6, 1 into 7, 1 into 6, 1 into 7. So this possible product is from this part. Similarly, this part is obtained from this one. 2 into 0, this one. 2 with 5, this one. 2 with 6, this one. 2 with 7, this one. Okay. Similarly, we have this part and this part. This matrix and this element. And after simplifying, we can get this matrix. So this is equal to this one. So this is the all possible product. Okay. So the order of this this is of 2 by 2, and the order of this one is 2 by 2. So 2 into 2, 4, and 2 into 2, 4. So the new matrix is of 4 by 4 order. This matrix is of 2 by 3. This the order of this one is 1, 2, 3, 4, 1, 2, 3, 4, 4 by 4. Okay. So this will be 2 into 4 and 3 by 4. Okay. So it is 8 by 12. 1, 2, 3, 4, 5, 6, 7, 8. And in this way, there are 12 columns. So the same rule which we discussed here is also applied at this place. And according to this one, you can get this part. 1 with this whole matrix, minus 4 is also with the whole, 7 is also with the whole. Similarly, we have minus 2 with the all, 3 is with the all, and 3 with all. And after simplifying, you will get this matrix. See in the MATLAB. If you want to execute this one, we can do in the MATLAB, and very quite easy. A and B. Okay. And function for the same we have is clone xy. We have A matrix, we have B matrix, CLC. A is equal to, we have 2, 3, colon 4, 5. B is equal to, we have 3, 2, colon 6, 5. Ground A, B. Sorry, A, B. So you can see this is the answer. So the canonical product is we can use this function. Okay, and we have the required answer. The order of A is 2 by 2, order of B is 2 by 2. That's why the order of this new matrix we have is 4 by 4. You got it? I think it is very clear to all of you, all the participants who are attending this session online. M. Kamran Alam, Abub, thank you. Sani Saleh, thank you. Jacob, thank you all participants who are attending this session. And you must invite all your friends, colleagues, you must share with your friends so that we can make successful this series, and this series will be possible because of your participation. Thank you all. Now, eigenvalues and eigenvector, all of you are very familiar, all these. Okay. Eigenvalues and eigenvectors of a square matrix A are respectively scalar lambda and non-zero vector V. They satisfy the condition AV is equal to lambda V. The eigenvalues and eigenvector features prominently in the analysis of linear transformation, originally used to study principal axis of the rotation, motion of the rigid bodies. Eigenvalues and eigenvector have a wide range of application. For example, stability analysis, vibration analysis, atomic orbital, facial recognition, etc. Various type of applications are there of eigenvalues and eigenvectors. So now the thing is how we can calculate eigenvalues and eigenvector in the MATLAB. This is very simple way to find out, to use all this. Okay. Easily we can calculate all these operations and we can apply them to find out eigenvalues and eigenvectors. So if we are given this A matrix, A is equal to, we have 3, 1, 0, 0, 3, 1, 0, 0, 3. Okay, so to calculate eigenvalues and eigenvectors, Vd is equal to, we have this eigenfunction is inbuilt in the MATLAB. We will use. So we have V and D. Okay. So this will give V and D. So these are the eigenvectors. And D will give us the diagonal. These diagonal elements are the eigenvalues. A has repeated eigenvalues and eigenvectors are not independent. This means that A is not diagonalizable and is therefore, if you want to check, verify V and D satisfy the equation AV is equal to VD. We can do. Okay, so if you want to find out the eigenvalues and eigenvector in the MATLAB, we can use in this way. A is equal to, suppose we have this matrix, we can randomly choose any one. 2, 3, 4, semicolon, 7, 6, 5, and 4, 5, 7. Okay. So V, comma D is equal to eigen, EIG of A. So you can see here the values of V are the eigenvectors and the diagonal element of D are the eigenvalues. These are the eigenvalues and you can easily check this. The vectors are the column element of this matrix. This is corresponding to this value. This is corresponding to the second value. This is corresponding to the third value. So in this way, these values will be exist. Okay. Okay. So thank you. This is my presentation for the today's session. and I hope the content which I tried to present here is very useful, very helpful, very informative. Your feedback is always very important to us, and this series which we have started will be very beneficial to all of you if you are coming regular in this session, and also you can motivate your student, your friends, your colleagues, because many times we are getting many emails and to organize special sessions for their particular problems. But the thing is, when we have numerous queries and it becomes very, very typical tough job to justify everyone and to give much time. That's why we started this series, so that everyone who are not capable to register, many times they are not able to pay the fee for paid event, and there are many participants from different type of zone, like Ethiopians are always face many problems. There are many African countries where sometimes different time zone they are not able to join these events, and that's why we started this series, so that all the lectures which we will deliver through this platform will be always available for your kind help. And there are many students who try to request us to provide this content free available for their usability. This is the main reason to start this virtual series. So many things are behind their request from the participant, friends, colleagues. Okay, so the content must be available for their use, and on this platform all the lectures which we are trying to deliver will be always there. We will not remove this content. Okay, so along with we are going to launch our mobile app also. This mobile app will help you in many ways. Which events are coming up, you can easily put your prompts, you can easily download the content which we will upload there. But along with there will be some paid events, because this is becoming now huge platform, and there are many expenses to run this foundation. Okay, so the prices of the event, as you know, are always very less as compared to other programs. Just we need to need financial support to run this platform, to organize the various type of events, so that the growth of this foundation must be required. There are many employees who are working behind to manage all these things. That's why we need to organize some paid events also. Okay, but if there are some participants which are beginners in their career, and sometimes they are not able to pay their fees, but this must be not the obstacle for their career. If there is such person and need help from us, they can request us, and I'm sure we help you. But we need also support from your side. If you can share these links, this information with your friends, colleagues, this is our motivation. And also from where you can download this app, I will provide you the link. Just you need to go on the YouTube channel, and many of you don't know about the channel, and you can easily find out the list of all the lectures. Okay, so I am sharing just 1 minute. Yes, you can see here is you can find here YouTube, and when you go on the YouTube, just you need to search here MathTech Thinking Foundation. Enter here the name of the foundation, which is MathTech Thinking Foundation. Okay, so when you will enter the name of the foundation, this is the on the top. On the top you can find out all the things, and here is the playlist. When you go to the playlist and international short term, and then there is a MATLAB tutorial series. When you will click on it, okay, you understand, you can find out this is the ongoing event right now. Okay, and here you can find this is the first one. Okay, this is the complete list, and all the lectures will be available here. There is all the lectures. You can easily get all this, and the other information which will be available here when you will go to the description. Okay, here are the important links. You can find here important link. This is the event page. When you will click on it, the event page will open. So all the updates will be at this event page. This page is available on the official website of this foundation, MTTF.in. It is opening. Okay, and also here is a registration form, and along with today I will provide you the feedback form is also will be available there. Okay, if you are not registered till now, you can register here. When you will click on it, the form will open. Okay, you can see the registration form is opening, and you can submit your information. Okay, so here you can register, so that at the end you will get the certificate of participation. And feedback form will be also available here. After this session, I will provide you the link of the same, and you can submit your feedback also. Okay, and also to get the certificate of participation, your attendance must be at least 60% of the total. Okay, only then you will be able to get the certificate of participation. And during this series, we will cover numerous topics which will be very helpful to all of you. Okay, so all these will be very helpful to all of you. For the today, thank you very much for being the part of this event, and thank you very much. In the coming session, we will cover some new topic, and we will intimate you. Good night from India. Stay safe. Thank you once again.